Our ride was called Speed. The purpose of this experiment was to find the kinetic, potential, and mechanical energy, the centripetal acceleration, the centripetal force, and the tangent velocity for the ride. Background information. The ride Speed was originally designed by a Dutch company called KMG. It is distributed to the fairs in the United States by North American Midway Entertainment. The ride is usually built on one central trailer, and its construction time is about 2 to 3 hours if you have 2 people building it at the time. Basic pre-calculation ride stats. The height of the ride is about 37 meters. There's 4 people that fit on the car, and there's 2 cars, so 8 people ride the ride at once. The ride weighs 28 tons, and 1 revolution of the ride is 6.7 seconds.
Values that were given / found. The length of the arm, which is the diameter and also the height of the ride, was 37 meters. The radius of the arm was 18.5 since it was half of the length. Time per revolution, which we had earlier, was 6.7 seconds. The weight of the cart was 208 kilograms because of 70 kilograms per 4 people to a cart, which gives us 208 kilograms. And the gravity was 9.8 meters per second squared. So we found the centripetal force, which was the mass times the tangent velocity squared over the radius of the ride. And the mass was 208 kilograms times the velocity, tangent velocity, which is 17.35 meters per second. Then squaring it gave us 301.02 meters squared over second squared times the mass, 280 kilograms, which gives 84,285.6 kilograms per meters squared over second squared over 18.5 meters, which would finally give us 4,555.978 newtons, which we rounded down to 4.5 times 10 to the third newtons. Next, we had to find centripetal acceleration. So you have to do the tangent velocity, which is the same as the normal velocity since we did the circumference times the divided by the time. So it's still over the radius, so it was still 17.35 meters per second squared over 18.5 meters because that's the radius of the ride. So you got 301.02 meters squared over second squared divided by 18.5 meters, which gave us 16.27 meters per second squared, which we knocked down to 1.62 times 10 to the first meters per second squared to keep it even significant figure-wise. Alright, so for potential energy, you get the mass times gravity times the height of it. So the mass was 280 kg times the height of the ride, which is 37 meters, times gravity, which is 9.8 meters per second, thus giving us 101,528 joules, but we had to convert it down to significant figures, so we have 1.0 times 10 to the 5th joules. Next, we had to find mechanical energy, which is kinetic energy plus potential energy. So we just use our earlier numbers for kinetic and potential energy. So you get 42,000 joules times 42,000 joules plus 100,000 joules, which gives 142,000 joules, which we convert down to 1.4 times 10 to the 5th energy, which is half of the mass times the velocity squared. And so it was half times 280 kg, since the normal person is about 70 kilograms in size. So we times it by 4 because it's 4 to a cart. So when you times half by turn 8 kg, it's 140 kg. When we do our velocity squared, we got 301.02 meters squared over second squared, thus giving us 4.2 times 10 to the 4th joules due to us having to keep it in significant figures.
So, here, how we found RPMs is that one revolution was every 6.7 seconds. So we did the conversion for it to make revolutions per minute because there are 6 seconds in 1 minute. So therefore we had 8.95 revolutions per minute. Then for circumference, she did pi times the diameter of the circular motion that we went in. So, and the diameter is 37 meters, so pi times 37 meters gave us 116.24 meters. And velocity was the distance, aka the circumference, so it gave us 116.24 divided by 6.7 seconds, because that was the amount of time it took, which gave us 17.35 meters per second.
Discussion of error. The only error that we are worried about are not accurate times, which could cause both our velocity and tangent velocity to be different compared to what it should be. We also found out afterwards that the actual RPM of the ride was 13 RPM, which is way off compared to our other calculations of our RPM.